Hello guys, welcome to part 2 of chemistry, ionic, covalent, and metallic bonding. And now we're going to talk about metallic bonding. And so let's talk about metallic bonding first. Wait, I forgot to write the title. Sorry about that. So metallic bonding is definitely about metals. Everybody knows that. This is a piece of metal. It can be a piece of anything, I don't care. It's a piece of metal. So what you might think how metals exist because it's a pure piece of metal is like, well, it can only have a certain number of electrons based on the set. Look. This is an Fe1. And this is iron, as you can see. And let's go back to the periodic table. Yes, it has 26 electrons. And as you can see, boost knowledge told me it will have 6 extra electrons, or 4 less electrons in the outermost shell. So if I draw the outermost shell, it has 6 electrons, 1, 2, 3, 4, 5, 6, and you will combine with another Fe atom to make a full shell of, wait, this isn't correct. It will combine with another Fe atom to make a full shell of 10 electrons. Ha, I'm very smart. But you'll be dead wrong, because metallic bonding don't exist like this. They don't exist like covalent bonding or an ionic bonding. They actually don't even bond like this. Because the metallic bonding, all the extra electrons just float about. And all the Fe atoms with 4 shells, or any other atom it can be, just sits around in layers. So it's like 1 layer, 2 layer, etc. And the electrons are just floating about. It can just be anywhere. It's not connected to any atom or anything. And this is a good thing about it, because it makes it very stable. The atom, the Fe, the ion itself is very stable. It's not easily damaged or reacting. So it makes metals actually very good conductors of electricity. As you can see, there are many electrons out here, so they can conduct electricity or heat very easily. So most people will think, well guys, this can only be transition metals. There's literally no way pure sodium or pure potassium exists like this. But you're still wrong, because actually pure lithium, sodium, potassium, and anything that is counted as a metal, even if they can bond with other things, still exist in this way. So sodium is like this. I'm just drawing 2. And when it meets chlorine, it should be 2 electrons, so to specify. What actually happens is this electron goes to chlorine, this sodium goes to chlorine, and they become together. And this extra sodium with this electron is forgotten. That's actually what happens. So just to specify, it can actually happen with any type of metal, but it cannot happen with non-metals. So this is metallic bonding. Very easy to understand. Well, the next thing is a bit harder. Alloys. So what's an alloy? An alloy is a piece of metal with a non-metal. Wait. Isn't that ionic bonding? Boost Norris told me in the last video. A metal plus a non-metal is a ionic bonding. Wait, but you'll be wrong. Because ionic bonding is only called ionic bonding if they are ions. If the things in the alloy don't really react at all, well, it can't really be ionic bonding. For example, if you have lots of this thing called ion Fe in this, and the electrons are also floating around, but you also have pieces of carbon between it. This actually makes the atom more harder than before. More hard than before. No, not more hard, sorry. More hard than before. It will be not easier to break this atom than this. because the electrons are just scattered around, and the heat conductivity and the others will decrease a bit. But for example, steel is not an element. Stainless steel is not an element because there's still like 2% carbon in the metal. So that's alloys. And the last thing we're going to talk about is what I often write in these videos, dot and cross. Dot and cross diagrams. So when you see previously, let's see on the side, when I draw the Na+, Cl-, HF, HCl, or the Na3, O2, F2, Cl2 before, how did I do that? How did I just do a lot of dots and crosses together? Well, there's a reason for that, because there's literally a reason for that, because you have to express them in some way, and you have to express the electrons. The important thing is the electrons. You don't care about the protons, you don't care about the neutrons. They literally nearly never react. What reacts is the electrons moving about. Well, the neutrons can get in and out, but that's not what GCSE is focusing. That's isotopes. That's not what GCSE mainly focuses about. So, well, for example, if you wanted to draw a dot and cross diagram for any atom, for example, maybe you should just draw a simple one, H2. So firstly, we have to draw 2 hydrogen atoms and make them bit big as possible. One with dots representing electrons, one with crosses representing electrons. Why does it think it's very similar like noughts and crosses? So we have to make the dot and cross go together. Like this. Then we charge and put one of the dots over to the cross. This is something that you should be very careful about, because the dots and the crosses have to be a very far away distance from the main electron. And this is actually how it works, something like this, maybe. Maybe something like this. Well, everybody, it's a terrible drawing. I'm going to redraw it, because it's very hard doing it. Putting them together. So, well, this is a perfect diagram of H2. So, these are dot and cross diagrams. And there's something I also want to cover today. It's called completing the equation, or simplifying equations. For example, potassium oxide. So K plus O equals KO. No, that's not the equation. I'm going to tell you about the equation. So for most instances, we are talking about easy instances. Balancing the equation is also a new video entirely about it. Based on what we learned before about covalent bonding and diatomic bonding, there are still students who write this: K plus O equals KO. And I have to say, this is very normal, and there are guys that write other things. But as I said, O cannot exist. It must be O2 or O3. Mostly O2, actually. So, by writing O, if it's not combined with another element like CO or something, if it's just writing O plainly, that is definitely incorrect. And so you might say, okay, guys, it's so easy. K plus O2 equals KO2. That's literally nothing wrong with it. It's like CO2. However, you also be dead wrong, because you see, K was this outer shell of electrons. 1. Oxygen was the outer shell of electrons. 4. And now you come to realize there is literally no way you can make this electron go into another place and form a full shell. You're like, wait, what if we just gave this electron to oxygen? Yes, this potassium will have a full shell, but oxygen will still not, and this oxygen does not have a full shell. You're like, okay, potassium has inner shells. Let's just skip this 4, gives us 4, potassium still has a full shell. But then, firstly, potassium might not be able to give away so much shells, and also this oxygen and this oxygen will still not have full shells. So this does not work. So how is it possible to make it work? So let me clear everything again. The correct equation may surprise you. 4K plus O2 equals 2K2O. You might be like, what? K2O, how can that exist? Well, it can. For example, if you draw a potassium atom, like this. Oopsie, sorry. This is a potassium atom. And let's draw an oxygen one. This potassium wants an electron, and what we do is to give it electrons. But wait, how can you give it electrons? The way is for potassium to give oxygen electrons, the easiest way possible. Now oxygen has a full shell. Well, I just added 2 electrons. Well, oxygen should have 2 more electrons here. And this is what happens. The potassium have a full shell. Oxygens have a full shell. And literally what happens is, if I make it a very good looking dot and cross, well, the sizes are irrelevant, but don't care about that. And that's 2K2O. But wait, why can't we just do K2 plus O equals K2O? I explained that this is not good because you need O2. You need O2. So to balance this equation, to get this equation correct, you need to 1, know O2. Need know this O2. First, secondly, you have to draw diagrams. And for those people who haven't learned these dot and cross diagrams, I admit it's very hard. And you can't just remember what's on the outer shell. But wait, we have the periodic table. And if I change my color, you will know that potassium has 19 electrons. And according to this, it has 1 more than 18, 1 less than 20. And oxygen has 8. 2 less than 10. 8 more than 2. So you actually, with this, and the periodic table below, you actually can figure out the bonding with this quite easily. And you can do tests like this. You can complete tests in any of these forms, and I guarantee that it will be easy. Well, that's everything for this lesson. If you have any questions, please notify me in the comments, and we'll see you next time.